Last episode I mentioned that I don't need to know how squished my planet is. Well, it turns out I do need to know that for my calculations. So, let's start the exploration of day length and planetary rotation by looking at prograde and retrograde motion of planets. To break the concept itself down, prograde and retrograde just describes in which direction something moves relative to the direction of the rotation that the orbital parent has. So, since our Sun spins counterclockwise around its own axis, Earth's orbit, also being counterclockwise, is considered prograde. Since Venus turns clockwise though, which other direction, it is considered to turn retrograde. All the orbits of our planets and dwarf planets, Pluto, Charon, whoop whoop, are astronomically prograde. We have observed something quite similar with planetary rotation as well. 6 of our 8 planets spin prograde. Only Venus spins strictly retrograde, and Uranus has its axis of rotation turned by almost 100 degrees. Unfortunately for retrograde rotation and weird rotational axes, however, we have a few speculative explanations for how these came to be. Venus, for one, is theorized to have entered into its retrograde rotation via tidal forces, and that basically only causes extremely slow rotational speeds, so extremely long days. Isn't Venus also very similar to Eridani B from Project Hail Mary? I wonder why its rotation is so fast then. I'm sorry, I just have to remind myself that even Andy Weir can't out-pedantic his own readers, so why would I be able to? Okay, tangent aside, the weird axial tilt of Uranus doesn't inspire much hope in me either. It is speculated to have been caused either by several giant impacts, or considerably less likely, some orbital resonance stuff that I couldn't explain to you if I tried. Yet. Considering that I'm trying to build a binary planet, I have taken a look at the research there too. And so we know a few things about binary stars. Yeah, not much on planets, unfortunately, which is understandable. They may be possible, but well, we can only really take a close look at the planets in our own solar system, and well, we don't have a lot of binaries around. If we take Pluto, Charon, and indeed Earth-Moon as, let's say, distant analogs, we'll have no reason to assume retrograde rotation is any more common in binaries, as those all rotate prograde. And I do have to note that the binary should be assumed to have formed in the same process that flipped the axis, as such intricate orbits are rather less stable. To conclude what may be seen as a tangent, it is not unthinkable that a regular planet would rotate retrograde, and for some non-Earth-like worlds it may even be probable, but it would be prudent to assume that any Earth-like planet spins prograde unless there is a hypothesizable reason for retrograde motion. If retrograde motion seems interesting to you though, I'd advise reading through the exoplanet section in the Wikipedia article on it. My binary may have been created when an asteroid field in one of the Lagrange points of a gas giant was destabilized by some orbital mishap. Thus, a lot of mass was flung through its solar system, slowly drifting in eccentric orbits until much of it caught itself in a weird orbit with a planet roughly the size of Earth. Naturally, this destabilized the orbit, causing it to drift outwards and, with a lot of luck, finding a new stable orbit. Except binaries with nearly equal mass seem to be extremely rare in our universe. And well, one of the rules I have set for this project is that it is dragons all the way up. So let's introduce something weird. Something quite improbable, something fun that is meant to be questioned and make one of the planets turn retrograde. The L-Dragon to the Pegasus of otherwise realistic world building. God, I'm old. I do want to restate though, I understand that this is unrealistic. That's the whole point. The goal of realism in writing is, in part, to teach your readers how the real world works on an intuitive level. And something this glaringly improbable might inspire them to go out and educate themselves. Just how I'm educating myself in the pursuit of this writing. The effects of a retrograde rotation are rather minor. If you want to see them all unfold though, scribble that sub button. Anyways, planets which rotate retrograde to their solar orbit have days that are a minuscule bit shorter than those which turn prograde. And I mean like rounding error short. Unless of course you write a nearly tidally locked planet. Sunset and sunrise could be in the other direction. But notably, retrograde is defined by the rotation of a parent object. The trade winds too are affected by this. While the size of the Hadley cells relies on a couple of factors, including rotational speed of the planet, their direction is directly derived from the direction of the planet's spin. That would be a lot to get into right now, we will talk about that bit later. Thus, this is unfortunately all that I can say about the topic today. I do hope that there's more to explore though.